Hi, in this video I'm going to explain a third example for this net change theorem, and we start with the same setting. I'm just changing the question, and the question now is, what is the total distance traveled between 0 and 6 seconds? As you can see in the previous example, we saw that we got a net change in position of 0 fits because we did something pretty much like this. We went up with the ball and then we went down, so we ended up in the same level that we started. But now the question stands for total distance traveled, so I'm going to assign it total distance traveled. So I'm going to explain, for a different case. That's why I have this graph on the center. We start from these two functions that we found from the previous examples, acceleration and velocity. But I'm going to explain, this is obviously not the graph of this particular function of velocity. This is a different graph for a different velocity, but I'm just trying to use it for explaining purposes. So for example, if we see here on the graph, if we would integrate this interval between this point and this point, I'm going to call this I'm going to call this one A and B, we would see that this area would be positive, which in other words will be saying that whatever is moving with this velocity, whatever the object is, it will be moving to the right with this velocity. Now for the next interval, I'm going to call it A, B and C. Let's see, in this case the velocity, we can see the area will be negative, so we could see that in this case the object or whatever is moving to the left, and this velocity will be negative. Now for the last, I'm going to say here it's D. Here's D, and we would integrate this one, and we see a positive velocity, which is just like the previous first case. We get something like this. So the thing is, the total distance traveled in this case will be somewhere, this one minus this one and plus this one. But this would imply that for this interval, the object which is moving will be getting backwards. So that wouldn't be the total distance traveled. How do we solve this out in mathematics? Well, actually we have to do something like we have to basically multiply by -1 this interval. So I'm going to show you with this case. I'm going to start by taking this velocity. I'm going to ask myself, well, let's see, where this expression 32 plus t plus 96 is equal to 0, which is these points basically, because my goal here is to, using this net change theorem, I'm going to use this one in this way. I'm going to show you will be the integral between A and B. For normally we would just say for the net change something like this, right? But as we are considering the total distance traveled, we have to do something else. We have to try this velocity with its absolute value, which is what I'm going to find. What is the meaning of this in mathematics? So well, let's see how to find this. This will be negative 32 times t equal to -96. So we divide both sides by -32, right? 96 over 32, that's equal to 3. That is to say, I'm going to write here a super cool line. I'm going to write here time 3 seconds. Well, let's test for these intervals. So I'm going to pick a value for each interval. Let's say I'm going to pick here t equal to, I don't know, 0. I'm going to pick here t equal to 5, and let's see what we get. If I substitute t equal to 0 and this expression of velocity, we will clearly get, the first term will cancel out, and we get clearly a positive value. Here a positive value. And the thing is, with any value before 3, we'll always get a positive value. Now if I substitute t equal to 5 in this expression, as you can see, substituting t equal to 5 in here, it will clearly be, this negative side will clearly be above 96. So for every value of time after 3, time equal to 3, we always get a negative result. So basically, we're cool with this part of the expression. We just say, here we have velocity with respect to time. But what happened with this one? This one we represent going backwards. So we could get back to the beginning where we started from the previous example, but we are looking for the total distance traveled. So how we treat this in mathematics? Well, we basically take the velocity and we multiply it by -1. So that way we make everything to be positive and we are counting all the total distance traveled. Now, how do we translate this to this expression that we have on the right? So we will do something like this. We will split this. I'm going to do it down here in the center. Yeah. So we will split this integral between 0 and 3, which is this first interval. And we will take here velocity with respect to time, differential of time, which is this part. And then will be plus the integral between 3 and 6. But in this case, we're going to take this expression, negative velocity with respect to time. Negative velocity with respect to time. There it is. So, well, actually, I'm going to substitute this expression that we have for velocity. I'm going to do it in this step. Will be here is between 0 and 3. That is very ugly 3. There's better. It will be negative 32 time plus 96. This would be differential of time, and there would be plus. I'm going to substitute first, and then I will solve this out step by step. So here we got negative will be minus 32 times t plus 96 differential of time. So I'm going to use different color to sign this out. So this piece, it's velocity with respect to time, and this piece will be negative velocity with respect to time. So, well, after it, we just translate it to mathematics. So this is actually something very simple. I believe you will be able to solve this out on your own, but I'm going to solve it in here anyway. So the integral of this first v of t will be equal to negative 16 t squared, will be here plus 96 times t. Now all this will be evaluated between 0 and 3, and this will be plus, of course, this negative velocity of time will be just the same expression as the previous one, but just with the symbol signs switched. Will be positive 16t squared will be minus 96t, and we will evaluate this between 3 and 6 seconds. 3 and 6 seconds, there it is. So, well, I'm going to solve this out using a calculator. Now, the evaluation for 3, which is substitute, and here I'm going to, it will look like this: t squared plus 96 3. I'm going to use a bracket for it. This is with time equal to 3. It will be minus, I mean, of course, the second one will cancel out, but I'm going to write it anyway. It'll be like this. So this would be 16 0 squared plus 96 0. There it is. And there will be now a plus, which is, I'm going to use here plus. I'm going to continue in the second, the next row. So I'm going to evaluate first, will be 16 times with 6 squared, which I'm evaluating this value, will be minus 96 times 6. It will be here minus, I'm going to use brackets here. Now we'll get it's 16 times 3 squared will be minus 19 times 96 times 3. I'm going to use the bracket here. This bracket, And now the solution for all this when using a calculator is the first term, this one, it's equal to 288 minus 144. That's equal to, at the end, let's see, 144. As we are taking a total distance traveled, this will be in feet. I'm sorry, not meters, it will be in feet. Now, the second one, this second term would cancel out. And the third one, this one, it's actually 576 minus 576. This one actually can cancel out. It's going to cancel out. You can verify it using your calculator. And then here would be minus, the solution for this one, it's actually the same as the first one, but with a negative sign. The signs are inverted, so it would be, here would be negative 144 feet. So as we can see, it will be 144 plus 144. So at the end we have 288 feet, and this represents the total distance traveled. We made positive these intervals that were going on the opposite directions. So we got to this result, which is this is the full way to solve this out. Another way to solve it could have been just to calculate the, we know that the total distance, it went upwards and downwards in 6 seconds. So the distance to get to the peak of this trajectory would be 3 seconds. 3 seconds to get to the peak. So we can just, for example, the other way to solve this out would have been just integrating the distance between 0 and 3 seconds and then multiply it by 2. That would be another way, but this will work for parabolic. This could work for parabolic cases. Any other case, such as this one, would be kind of difficult to find this out in such a simple way. So, well, let's see. That would be all for this example.